Welcome to Factory on Air by DBR77, where smart manufacturing gets real. This is episode 4, Optimizing Production Processes for Greater Efficiency. Every production floor hides untapped potential in bottlenecks, idle time, and layout inefficiencies. In this episode, we reveal how to spot and solve hidden constraints using real-time data, 3D simulation, and AI-powered process analysis. You'll hear how furniture, automotive, and logistics companies increased throughput, reduced cycle times, and optimized internal flows, without costly trial and error. We'll also explore how DBR77's digital twin technology turns your factory into a living model you can analyze, simulate, and improve continuously. Factory on Air is brought to you by DBR77, the all-in-one platform combining IoT, digital twin, AI, and automation. We help manufacturers move from guesswork to precision. Let's dive in.
Have you ever stared at a complex operation, maybe, a busy factory floor, a bustling logistics center, or even just your own overflowing project list, and had that nagging feeling, that sense that there are hidden inefficiencies lurking just beneath the surface?
Oh, absolutely. It's that frustrating sense that time, money, energy, it's all quietly bleeding away.
Yeah.
But you can't quite put your finger on exactly where or why.
Right. And problems like a mysterious bottleneck or maybe an expensive machine just sitting idle, they often are obvious until they've already cost a fortune.
Exactly. By the time it's painfully clear, the damage is often done.
Well, today we're embarking on a deep dive into precisely that challenge. The intricate world of production process optimization. We're going to explore how cutting-edge data analysis, sophisticated simulations, and the power of artificial intelligence are fundamentally revolutionizing efficiency across industries.
It's a fascinating field, and the technology is moving incredibly fast.
It really is. Our source material for this deep dive includes a foundational document on, optimizing production for greater efficiency. And we're also looking at a comprehensive overview of a particularly interesting platform known as DBR77.
Yes, DBR77 provides some excellent real-world examples of these principles in action. It connects the theory to practice very effectively.
Great. So our mission today is clear. We want to equip you, our listener, with a shortcut to understanding how advanced technology not only pinpoints these hidden issues, but also provides clear, actionable pathways to dramatically boost productivity, conserve valuable resources, and ensure far smoother operations.
We're aiming to uncover how leading companies are moving light years beyond guesswork, how they're achieving truly remarkable gains.
And hopefully with just enough surprising insights to keep you hooked along the way. Okay, let's unpack this. When we talk about optimizing production, the first hurdle often isn't finding a solution, right? It's identifying the problem itself.
That's spot on.
Why is it so incredibly hard for companies, especially those with, sprawling production lines or complex logistics centers, to pinpoint exactly where they're losing time, money, and energy? What are those subtle signals, those easy-to-miss hints that something's just not quite right? The things often overlooked until they blossom into a major, costly issue.
That's a truly fundamental question, and it gets right to the core of the challenge. Essentially, we're talking about identifying what's known as a bottleneck.
Okay, the bottleneck. We hear that term a lot.
We do. And imagine it like the narrowest point in a pipeline, or maybe think of a single-lane closure on a multi-lane highway during rush hour. It's the limiting factor. It's that single stage or workstation in an entire process whose limited capacity slows down the entire flow of production. Everything downstream is affected.
Ah, okay. So it dictates the pace for everything else.
Precisely. For example, you might have a state-of-the-art machine, brilliant piece of kit, capable of processing 100 units per hour. But if the station before it can only consistently feed it 50 units per hour, well, that first, slower station becomes your bottleneck.
Even though it's not the fancy new machine.
Exactly. The bottleneck dictates the pace for the entire line, meaning your cutting-edge machine is only ever working at half its potential. Huge waste of capacity.
So it's not always the slowest or most obviously broken machine, but the one that restricts everything else. Makes sense? And what are some of those common, maybe visible symptoms of these hidden inefficiencies? The things a production manager might walk past every day without fully grasping their true significance or the scale of the waste they represent.
Yeah, you can often see the physical manifestations even if the underlying root cause isn't immediately clear. A classic visual cue is seeing piles of semi-finished products accumulating before a specific workstation, just stacks of work in progress.
Right, the inventory buildup.
That backlog basically screams that the workstation is struggling to keep up with the incoming flow, the bottleneck right there. Conversely, you might observe machines in subsequent stages just sitting idle, sometimes for minutes, sometimes for much longer.
Just waiting.
Simply waiting for materials to arrive from an upstream process. That idle time is pure waste. It's essentially money sitting still, doing nothing.
Isn't that another sign?
Another pervasive symptom is uneven resource utilization. You walk the floor, and some machines or work areas are visibly overloaded, buzzing with frantic activity, people rushing around, while others sit conspicuously underutilized, quiet. It indicates a significant imbalance in the overall production line design, or maybe just the daily operation.
And like having half your team working flat out while the other half waits for tasks.
Exactly, that kind of imbalance. It's inefficient and often stressful for the overloaded areas.
And it's those moments, isn't it? Those seemingly minor cues or brief idle times that can really add up to enormous losses over time. What's often misunderstood about these small inefficiencies?
Well, what's truly fascinating and often overlooked is how these critical points can remain hidden without a deeper, data-driven analysis. We're not just talking about obvious hours-long machine breakdowns that everyone notices and scrambles to fix.
No, the big dramatic failures.
Right. We're talking about micro downtimes. These are brief, often unnoticed pauses that happen countless times a day. Think about a machine waiting just 10 seconds for the next part to load, or an operator briefly looking for a tool, or maybe a slight adjustment taking a few seconds longer than expected.
Tiny little interruptions.
Tiny, yes, or subtle variations in cycle times, where one batch might take slightly longer than another for some unknown reason. The cumulative effect of hundreds or thousands of these small, seemingly insignificant inefficiencies adds up to truly colossal losses in productivity and profitability over time. It's death by 1,000 cuts, really.
So the cost of guesswork is just huge then.
Immense. Without precise, objective data, trying to optimize process is it's like trying to navigate a complex maze blindfolded. You might stumble upon some superficial improvements, maybe you get lucky, but it's mostly reactive solutions, not proactive, strategic improvements that fundamentally address the core issues.
Patching things up instead of fixing the foundation.
Exactly. You simply cannot manage what you don't accurately measure, and you certainly can't truly optimize it.
Okay, so if intuition, observation, even traditional time studies aren't enough to capture this granular reality, what kind of information do we actually need? What are the key data points that transform that guesswork into genuinely informed, impactful decisions?
You've highlighted the absolute bedrock of modern optimization, the necessity of hard data. This isn't about gut feelings or, well, I think this machine seems slow. It's about objective, quantitative data that captures the reality of the operation.
Undeniable facts.
Precisely. This is the unshakable foundation upon which any successful optimization strategy must be built. Without it, you're just speculating. You're hoping.
So, in a tangible sense, what does that hard data look like in a real-world production environment? What specific parameters are we actually talking about measuring, and why are they so crucial?
Okay, so for a truly comprehensive production analysis, you need several key data points, and these need to be accurate. First, precise operation times. How long each individual step genuinely takes, measured down to the second, ideally. Not just what's planned or estimated in a spreadsheet somewhere.
The actual time, not the theoretical time.
Exactly. This reveals hidden delays and true processing rates. Second, material flow. This means understanding the exact movement and sequencing of goods as they pass through the entire system. Where are items at any given moment? When do they move? What exact path do they take? This helps identify logistical inefficiencies like, unnecessary travel, those traffic jams we mentioned.
Okay, so how long things take and where they go. What else?
Third, machine availability. This is crucial. It's the actual uptime versus the planned uptime. How much of the time is a machine truly ready to work, and how much is it down for maintenance, waiting for materials, changeovers, or other unforeseen reasons?
Right. Is it capable of working?
Exactly. This highlights bottlenecks caused by machine reliability or scheduling issues. Fourth, error rates. Identifying precisely where mistakes or quality issues occur in the process, not just finding them at the final inspection point when it's too late.
Catching problems earlier.
Much earlier. This pinpoints problematic steps or equipment causing defects. And finally, resource utilization. We need detailed insights into how personnel and machinery are actually being used. Are they working at their optimal capacity? Or are they frequently idle? And importantly, for what reasons.
Wow, okay. That's a lot of data points.
It is. But this granular data, taken together, paints a picture that no amount of human observation, no matter how diligent, could ever fully capture on its own.
Which raises the big question. How do you even get all this data, especially the real-time granular kind you're describing, across maybe a vast factory floor? This sounds like a massive, maybe even prohibitively expensive undertaking for many companies.
That's a very fair point, and historically, it was incredibly difficult and expensive.
But this is where modern technology steps in, right? Transforming that chaotic real-world activity into a clear, measurable picture.
Absolutely. This is precisely where advanced solutions such as the kind of sophisticated Internet of Things or IoT system that DBR77 offers truly shine. They provide the practical means to collect this critical data with unprecedented accuracy and efficiency.
Well, DBR77 doesn't just rely on generic, off-the-shelf devices. They leverage their own specialized sensors. These are installed directly on machines and strategically placed throughout the plant. And these aren't just simple motion detectors. They're purpose-built for industrial precision.
Industrial grade. Exactly. Designed to monitor specific critical parameters, things like temperature, pressure, vibration, energy consumption, and crucially, precise machine operating time, cycle counts, status codes. They're specifically engineered to capture the subtle nuances of industrial operations that standard sensors might miss.
So purpose-built industrial sensors, not just consumer gadgets adapted for a factory. Got it. And they're collecting data continuously, creating a constant digital pulse from the factory floor.
Exactly. We're talking about true real-time data collection. This means data flows continuously without interruption from these sensors to a central analytical platform like the one DBR77 provides. This constant live stream allows for immediate analysis and, crucially, immediate course correction.
Ah, so you see problems almost as they happen.
Almost instantly. If something goes wrong or a bottleneck begins to form or a machine starts behaving unusually, you know about it right away, not hours or days later when the problem has already escalated and cost you significant money or time.
That makes a huge difference.
It's transformational. The benefits of this granular IoT data are profound. You achieve vastly increased data accuracy because it's coming directly from the operational source, unbiased. You get significantly reduced analysis time because the data is already structured and flowing into intelligent systems ready for processing. And you see substantially lower costs for acquiring this crucial operational information compared to any manual collection methods, think stopwatches and clipboards, which are incredibly time-consuming and often inaccurate.
Right, automating the data gathering.
Ultimately, this translates directly into far superior operational management and faster, more accurate decision-making for the entire enterprise. It means systematic data collection enables objective problem identification, allows you to precisely track the effectiveness of any implemented improvements to that change actually work, and it helps you maintain peak efficiency over time because you're constantly monitoring and adjusting like a highly tuned machine itself.
Right. Here's where it gets really interesting for me. Once you have all this incredibly detailed data, all these deep insights into how your current operations are actually performing, how do you then leverage that? How do you test out new ideas, try different configurations or processes without, risking your entire production line, without causing a massive, potentially catastrophic disruption?
Yes.
This sounds like something out of a futuristic sci-fi movie, but you're saying it's very real, isn't it?
It is absolutely real and is one of the most transformative aspects of modern industrial optimization. This is the indispensable role of simulations.
Simulations, okay.
Simulations allow companies to model and test various operational scenarios entirely virtually, in a digital sandbox, essentially. The immense beauty and power of this is that you can experiment with completely different layouts, adjust machine settings, change staffing levels, even implement entirely new process flows, literally anything you can imagine, all within a secure digital environment, without any risk whatsoever of disrupting your live production.
So you can try radical ideas without breaking anything.
Exactly. You can fail fast and fail cheaply in the virtual world. You learn invaluable lessons, refine your strategies, identify potential pitfalls, all before touching a single physical machine or reallocating any real resources.
That's huge. So what are some of the most impactful what-if scenarios that companies are exploring with this technology? Give us some practical examples of how this translates into tangible benefits.
Oh, the possibilities are quite broad and deeply impactful. For instance, companies can test completely new layout reorganizations for production lines or even entire facilities. Imagine being able to try out 5 different factory floor plans virtually, maybe shifting where machines are, how materials flow,
And instantly see the impact.
instantly see their projected impact on efficiency, material travel distance, potential bottlenecks, worker ergonomics, all without moving a single heavy piece of equipment.
Wow. Okay. What else?
You can also thoroughly evaluate the workforce impact. Simulate how changing the number of operators on a line affects overall output, or explore how cross-training different roles affects flexibility and resilience during peak times or, unexpected absences. How robust is the system if someone calls in sick?
Testing the human element, too.
Absolutely. And of course, you can perform deep process optimization, refining the precise sequence of operations, maybe changing batch sizes or adjusting the arrangement of machinery to significantly improve flow and eliminate those bottlenecks we discussed earlier. Thanks to simulations, you can objectively compare several variants, analyze their projected outcomes, throughput, cost, lead time, and confidently choose the best solution before any real-world implementation.
Saving tremendous resources and avoiding those costly mistakes.
Exactly. It de-risks innovation significantly.
Now, if we connect this to the bigger picture, you hear the term digital twin a lot these days. This sounds like it takes simulation to an entirely new level, right? It's not just a hypothetical model. It's more like a living, breathing, continuously updated replica of your physical operations.
That's absolutely right. A digital twin is much more than a static simulation model.
Tell us more about DBR77's approach to this. What makes their digital twin technology so powerful?
Okay, so DBR77's digital twin technology creates a precise virtual and mathematical model of a real production plant or logistics center. It's a digital replica. But what makes it so revolutionary is its deep integration. This 3D model isn't static. It's dynamically built upon and constantly fed by that real-time data streaming directly from their IoT system we talked about.
So the sensors feed the twin.
Continuously. This means it faithfully replicates every production line, every individual machine status, and every material flow within the physical plant in astonishing detail. It's truly a dynamic mirror image of the real world, updated instantly as things happen on the floor. So it's far more than just a digital drawing or a basic simulation. It's an active, responsive model that can maybe even predict future outcomes. That sounds incredibly powerful for proactive decision-making.
Precisely. That's where the real power lies. The digital twin employs advanced algorithms and a technique called stochastic scenario analysis.
Stochastic. What does that mean in this context?
To put it simply, stochastic means it accounts for unpredictability and randomness in real-world operations. Things don't always run perfectly, right? Machines have slight variations, operators take breaks, materials might be delayed. Stochastic models factor in this variability, rather than assuming everything runs perfectly like clockwork, which deterministic models often do. This allows for far more robust and realistic predictions.
Okay, so it's more like the messy real world.
Exactly. By running these simulations with real-time data feeding the model and incorporating this stochastic element, the digital twin helps identify hidden bottlenecks that only emerge under certain conditions. It can predict potential downtimes based on subtle performance degradation and even forecast future performance challenges before they occur in the physical world.
So you could see a problem developing in the twin before it actually stops the line.
That's the goal. Imagine seeing a queue forming in your digital twin at a specific workstation, or a machine showing early signs of wear through sensor data reflected in the twin, and knowing exactly which physical asset is about to become a problem, giving you precious time to intervene proactively. Schedule maintenance, reroute work, adjust settings.
And I saw in the materials that the DBR77 platform takes this even further with virtual reality and augmented reality integration. That sounds incredibly immersive, like a revolutionary way to interact with all this data.
It does, and it's a genuine game changer for understanding, collaboration, and even training. DBR77 integrates virtual reality, VR, and augmented reality, AR, to allow managers, engineers, and even frontline operators to see and interact with simulated solutions in a highly realistic, immersive environment.
How does that work in practice?
Imagine a plant manager putting on a VR headset and virtually walking through a newly designed factory layout that only exists in the digital twin. They can interact with simulated machinery, see the flow, experience the proposed changes as if they were physically there.
Wow, okay. And AR.
Or think about using a tablet with AR capabilities. You hold it up on the actual factory floor, and it overlays real-time data points from the digital twin directly onto the physical machines you're looking at, maybe showing current speed, temperature, or time until next maintenance.
That bridges the digital and physical worlds.
Completely. This dramatically enhances understanding, especially for complex systems. It facilitates far better communication and buy-in among diverse teams. Engineers, managers, operators can all see the same thing. And crucially, it minimizes errors before any actual physical implementation takes place because you've explored it so thoroughly in the virtual space.
So the value proposition seems pretty clear.
It's direct and substantial. This functionality directly contributes to significantly reducing operational costs, boosting overall efficiency, and drastically shortening response times to rapidly changing production conditions or customer demands. It effectively brings future possibilities and potential problems into the present for decision makers, allowing them to make truly informed choices with much higher confidence.
It sounds incredibly powerful in theory and certainly futuristic, but where do we see this making a tangible, quantifiable difference for companies right now? Can you give us some real-world examples of businesses that have actually leveraged these insights, the data, the simulation, the digital twin, to boost their efficiency and see truly remarkable, measurable results?
Absolutely. And this is important, right? Moving from theory to practice. The documents provide some very compelling illustrative success stories that demonstrate these aren't just theoretical gains. They translate into significant, measurable improvements in the real world. For instance, there was a case with a furniture factory.
Okay, furniture. What was their issue?
They faced persistent delays and backlogs. Things just weren't flowing smoothly. By rigorously collecting data on material flow, where were things moving, where were they getting stuck, and then using simulations, specifically within a platform like DBR77s, to reorganize their production line layout, they achieved a remarkable 22% increase in efficiency.
22%? That's huge. Did they buy new machines?
That's what's really surprising about this particular case. This significant jump didn't require massive capital investment in new machinery. The 22% efficiency gain came almost entirely from optimizing the existing resources, just arranging them better based on the simulation insights. It revealed just how much latent capacity was hidden in their current setup, simply waiting to be unlocked by smarter organization. Their biggest bottleneck wasn't a slow machine, it was a hidden traffic jam in their layout that nobody had ever accurately measured or visualized before.
Wow. That's a profound improvement just from rethinking the flow and layout based on data. What about other industries, like automotive, which is known for its precision and complexity?
Good example. In the highly competitive automotive sector, an automotive components manufacturer was struggling with long production cycle times. They just couldn't get parts out fast enough. They utilized detailed data collection and simulations to meticulously balance their production line.
Line balancing. What does that involve exactly?
Yeah. It isn't just about making individual machines faster. It's about ensuring that each step of the process is perfectly synchronized and optimized relative to the others. You want work content distributed evenly. The goal is to eliminate those idle times and mini-queues we discussed earlier, making the flow as smooth and continuous as possible.
Okay, got it. And the result?
Result was an impressive 18% reduction in production cycle time.
18% faster.
Exactly. This means they could produce components much faster, directly impacting their output, delivery schedules, and ultimately their competitive edge in a very demanding market. It revealed that small imbalances, maybe just a few seconds here and there at multiple points, can create a huge cumulative drag on overall performance.
Makes sense. And what about in logistics? Warehouses, distribution centers, where movement speed and accuracy are absolutely everything.
Another great example. For a large logistics facility, internal transport routes, how forklifts or automated guided vehicles moved around were causing significant delays in order fulfillment.
Seems like a minor detail, maybe.
You might think so, but in a vast warehouse, inefficient roads can lead to massive time sinks. Miles of unnecessary travel per day, per vehicle. By optimizing these internal transport routes through data analysis, tracking vehicle movements, and simulation, testing new paths, they shortened their order fulfillment time by a significant 15%.
15% quicker from order to shipment.
Correct. This directly translated into faster customer deliveries, increased throughput for the facility, and likely lower fuel or energy costs for their internal transport. These examples, and others like them, aren't just isolated incidents or lucky breaks. They demonstrate a consistent, proven pattern of measurable improvements. Improvements achieved when data-driven insights, particularly those derived from automated process analysis and advanced simulations like those offered by DBR77, are applied systematically.
The common thread seems to be the ability to see and test what was previously invisible or just guessed at.
That's exactly it, making the invisible visible.
So these are real, quantifiable benefits that definitely impact the bottom line. And this is clearly where a platform like DBR7C7's automated analysis really shines, isn't it? Transforming that raw data into these actionable insights.
It truly is. DBR77's automated process analysis brings several profound benefits that move companies beyond traditional, often slow and subjective methods. First, it offers faster problem detection. Because the system is analyzing data in real time, it flags issues much more quickly, often before they become critical or even noticeable through manual observation. It eliminates the need for time-consuming manual audits.
So speed is key.
Speed and objectivity. Second, there's a vastly enhanced accuracy and objectivity in the analyses. They are based on real, unbiased data captured directly from the source, the machines, the sensors. Not human interpretation, estimation, or potential bias. This builds undeniable confidence in the results and the decisions based on them.
More trustworthy insights.
Absolutely.
Yeah.
Third, it enables genuine continuous optimization. This is really important. It's not a one-off project. Instead of reactive firefighting when problems become critical, companies can make ongoing proactive adjustments based on the continuous data flow, helping them maintain and even incrementally improve efficiency over time. It becomes part of the operational rhythm.
Always refining.
Always refining. And finally, it leads to very significant time and resource savings. Think about the cost of engineers manually collecting data, building complex spreadsheets, running lengthy analyses. The platform automates much of this and allows users to quickly test various solution options in that virtual environment, avoiding costly real-world trials and errors, which can be immensely expensive and disruptive to production.
And it sounds like DBR77 takes it even a step further, almost providing like an expert consultant built directly into the platform itself, not just presenting data, but actually suggesting solutions.
That's an excellent way to conceptualize it, yes. DBR77 leverages sophisticated AI algorithms that tirelessly analyze vast amounts of this operational data. They're designed to identify inefficiencies, predict potential failures, like a machine needing maintenance before it breaks down, and proactively suggest optimal actions.
So the AI is doing the analysis and offering recommendations.
Exactly. This AI acts, in effect, as a virtual lean consultant. It's constantly looking for subtle patterns, correlations, and ways to improve the process, operating at a scale and speed far beyond what any human team could manually track or analyze. This includes advanced machine learning for developing highly accurate predictive models. For instance, predicting tool wear or potential quality defects based on sensor readings.
Looking ahead.
And it also features automated report generation, which provides managers with clear, concise, actionable insights without them needing to wade through mountains of raw data or spend hours crunching numbers.
So it tells you what matters.
It surfaces the critical information. It's like having an army of data scientists and process engineers working nonstop in the background, identifying problems and opportunities you might have missed entirely. For instance, the AI might detect a subtle correlation between a specific batch of raw material from a certain supplier and a minor increase in cycle time or energy consumption at a downstream machine, something almost impossible for a human to spot easily.
And then it flags it.
It flags it, and might even suggest a preemptive adjustment in machine settings for that material, or perhaps trigger a quality check alert. It connects the dots across the whole process.
This all sounds incredibly beneficial, almost. Well, almost too good to be true in some ways. But we know implementing new technologies and fundamentally changing established ways of working can be a real minefield for any organization.
Oh, absolutely. The people side and the integration side are often the biggest hurdles.
So what are some of the most common hurdles companies face when trying to optimize their processes with these advanced solutions? And importantly, how are modern platforms like DBR77 specifically designed to overcome them?
You're absolutely right. The implementation phase often presents its own set of significant practical challenges. Let's kick through some common ones. One of the most common and persistent is simply employee resistance. It's a natural human tendency, isn't it? To resist changes to established procedures, especially when new, potentially intimidating technology is involved.
Fear of the unknown, maybe fear of being replaced.
Yeah, actually, people are comfortable with what they know. Fear of the unknown, fear of job displacement, even just the hassle of learning something new, it's all real.
Yeah.
Then there's the very practical concern of production disruptions. There's an inherent significant risk of halting or slowing down live operations during new system implementation or physical layout changes. That downtime is incredibly costly.
You can't afford to stop the line for too long. And on the technical side, integrating new systems with older established ones, that can't be easy, right? That sounds like a massive technical headache waiting to happen.
Precisely. Integration complexity is a major hurdle. Companies often have a patchwork of existing systems, maybe some legacy enterprise resource planning, ERP, manufacturing execution systems, MES, or warehouse management systems, WMS. Connecting new advanced solutions seamlessly with these, getting them to talk to each other reliably, can be a technical nightmare, requiring specialized skills and significant effort.
And the people using the new system.
Right. Finally, there's personnel training. New tools and procedures inevitably require employees to upskill or reskill, and that takes significant time, resources, and planning, which is often underestimated in the initial project scope.
Okay, so resistance, disruption, integration complexity, training needs, that's a lot to navigate. This raises an important question. How do you introduce such transformative technology without causing more problems than you solve, especially for companies that might be new to this level of digitalization or perhaps wary of complex, costly deployments?
It's a critical question, and platforms like DBR77 have had to think very strategically about addressing these typical pain points, focusing on accessibility and simplicity. Let's start with that perception of a high entry barrier for maybe more traditional firms or SMEs.
Okay, how do they lower that barrier?
DBR77 solutions are consciously designed with a human-centric philosophy. They emphasize simplicity and intuitiveness in their user interfaces. The goal is that users of all tech levels, not just engineers, can quickly grasp the core functionalities after just a few hours of training. This significantly reduces the need for costly external IT experts or extensive internal training programs just to get started.
Making it less intimidating.
Exactly. And they also invest heavily in comprehensive educational support. They offer extensive materials like detailed case studies showing real results, their dedicated online DBR77 Academy with training modules, and insightful webinars, all designed to demystify concepts like the digital twin and help companies understand its real value proposition without needing a huge upfront investment in just figuring out what it is.
That pragmatic approach makes perfect sense. Simplification is definitely key. But what about much larger organizations? Those with incredibly complex, entrenched existing IT ecosystems? Integration sounds like a monumental task there.
For simplifying complex implementation in large organizations, DBR77 takes a crucial strategic step. It operates entirely in a browser-based environment. It's a SaaS solution.
Ah, so no big software installs needed.
Correct. This eliminates the need for major modifications to the client's existing IT infrastructure. No heavy software installations on local machines, no complex server reconfigurations needed on their end. This makes deployment much smoother, faster, and less disruptive.
Okay, that helps. But getting it to talk to their existing ERP or MES?
That's where their robust application programming interface or API comes in. It's carefully designed for seamless connectivity and data exchange with those existing ERP, MES, or WMS systems. And importantly, their dedicated IT team actively supports these integration projects, working with the client's IT department to minimize both the time costs and, critically, the risk of production downtime during the integration phase.
So they help bridge that gap. Fair enough. But what about the quality of the data itself? We talked about needing hard data. If the data feeding the digital twin isn't accurate or complete, then the twin isn't really useful, is it? That's a huge dependency.
That's a critical point.
Yeah.
Data quality dependence. Garbage in, garbage out, as they say. The effectiveness of the AI algorithms and the reliability of the simulations rely directly on the quality and completeness of the input data. If the underlying sensor infrastructure is weak, or the data collected is inaccurate, the results will be unreliable, leading to potentially poor decisions.
So how does DBR77 tackle that foundational issue?
They address this head-on by offering their own integrated hardware solutions, including those specialized IoT sensors we discussed earlier, and robust data collection systems designed specifically for production lines. This helps ensure reliable and precise data input right from the source. But what's quite unique and particularly valuable for companies just starting their digitalization journey is that they also provide a standard database for initial simulations.
What does that mean?
It means a company can perform preliminary analyses and even run powerful what-if simulations using DBR77's platform, even when they might have incomplete live data from their own systems initially. They can use industry-standard data or anonymized benchmarks to get started.
Ah, so they can see the potential even before their own sensors are fully deployed.
Exactly. While the precision might be slightly lower compared to using their own live granular data, it's often more than sufficient to identify major problems, demonstrate significant areas for improvement, and show the potential value right from the start. It proves the concept quickly.
That's a clever way to lower the initial barrier and show value quickly. Makes sense. But the market for these advanced industrial solutions is incredibly competitive, isn't it? Dominated by huge industrial giants. How does a platform like DBR77 contend with the Siemens and ABBs of the world?
That's the competition from big players challenge, and it's very real. DBR77 strategically focused initially on the small and medium-sized enterprise SME segment. This segment is often overlooked by the tech giants like Siemens or ABB, who typically target massive, bespoke, multi-million-dollar projects with large corporations.
So they found a niche.
They did. However, DBR77's simplified implementation model, the rapid return on investment they demonstrate, and their compelling results have also increasingly attracted larger corporations. These bigger companies are often looking for more agile, flexible, and cost-effective solutions, perhaps for specific lines or plants, compared to the monolithic systems from the giants.
So flexibility is key.
Flexibility and a significantly lower starting cost. DBR77 often operates on an accessible subscription model, SaaS. This contrasts sharply with competitor solutions that can run into hundreds of thousands or even millions of euros just for the initial deployment and licensing. This accessibility makes them highly attractive across a broader spectrum of businesses, not just SMEs anymore.
That pricing model difference is huge. Now, industrial clients, especially larger ones, are often known for having a very long decision-making cycle for adopting new technology. It's often due to the scale of investment, the perceived risk. How does DBR77 help to speed that process up?
Yeah, the long decision cycle is certainly a significant hurdle in this industry. Change takes time, especially with core production systems. DBR77 tackles this by actively promoting small-scale pilot projects.
Starting small.
Exactly. This allows clients to test and verify results quickly in a limited, contained scope, maybe on a single production line or for a specific problem area. This dramatically reduces the perceived risk and the scale of the initial commitment. The accessible subscription model also helps here, avoiding those high upfront capital expenditure hurdles that often require many levels of approval and slow things down.
Lower initial costs, less risk.
Right. With a low entry barrier and a demonstrated rapid return on investment from these focused pilots, clients are far more likely to gain confidence and make quicker decisions about committing to a full implementation after seeing tangible results in their own environment.
Seeing is believing, basically. What about the network aspect? Building a robust ecosystem of implementation partners seems absolutely essential for scaling such a sophisticated platform, especially internationally.
It is absolutely crucial. You can't do it all yourself. To build a strong integration partner network, DBR77 has created the DBR77 Marketplace.
The marketplace? Tell me more.
This is a pivotal, innovative solution. It's an online platform connecting companies, the clients, with an extensive network of over 800 technology suppliers, hardware, software add-ons, and 600 system integrators, the companies who help implement the solutions. This makes it arguably the largest platform of its kind, focused specifically on production and logistics optimization in this industrial niche.
So it's like a hub.
Exactly. It functions as a true one-stop shop for implementation needs. It not only makes it easier for clients to find the right expertise or technology for their specific needs, but also provides a direct project pipeline for the integrators and suppliers. It accelerates transactions and fosters business growth for everyone involved in the ecosystem.
Creating a community around the platform.
Precisely. It's about building a collaborative ecosystem, not just selling software.
Okay, let's talk security. Data security and cloud processing concerns are always top of mind for industrial companies, especially when we're talking about highly sensitive production data, process details, maybe even intellectual property. How are they addressing those very valid concerns?
This directly addresses the cloud data processing concerns issue, and it's non-negotiable for industrial clients. DBR77 understands the paramount importance of data security and regulatory compliance. Their system operates with the highest security standards, evidenced by their ISO 27001 certification. That's a globally recognized benchmark for information security management systems.
Okay, ISO 27001. That's a serious certification.
It is. Furthermore, for their European clients, all data is stored on AWS Amazon Web Services, servers located in Frankfurt, Germany. This ensures full compliance with the stringent GDPR regulations for data protection within the European Union. Data residency is key.
And the access.
Crucially, it's a strictly B2B platform. All users, clients, integrators, suppliers accessing the marketplace or platform sign mutual non-disclosure agreements, NDAs. This legally protects that highly sensitive production data and any shared intellectual property. It builds a robust framework of trust and confidentiality.
Good, that seems thorough. What about expanding internationally? Different regulations, different market dynamics, different languages. That sounds like a whole new set of challenges.
It absolutely is. International expansion requires a careful strategy. DBR77 takes a highly strategic and localized approach rather than just trying to sell the same thing everywhere. They actively collaborate with local system integrators and distributors in their target markets. Many of their existing partners, especially the larger ones found via the marketplace, already operate internationally.
Leveraging existing networks.
Exactly. This significantly simplifies the adaptation of the solution to specific local market requirements, cultural nuances, business practices, and language barriers. This strategy helps accelerate the expansion process into new regions like Germany, the USA, and Asia, leveraging existing relationships and localized expertise rather than trying to build everything from scratch in each new country.
Smart. And finally, the bottom line again, ROI. Industrial clients demand high return on investment. If they don't see clear, measurable financial benefits quickly, they simply won't continue using the platform or expand its use. How does DBR77 ensure high ROI requirements are met and exceeded?
Precisely. High ROI requirements are absolutely critical for adoption and retention in this sector. DBR77 addresses this directly through several factors we've touched on. Firstly, the low initial cost due to the subscription model and the pilot project approach directly contributes to achieving a rapid return on investment. Companies see value quickly without massive upfront capital outlay. Secondly, the integrated marketplace helps clients choose the most optimal and cost-effective solutions and technologies for their specific plant needs, avoiding overspending on unnecessary features or incompatible hardware.
Finding the right fit faster.
Yes. This further shortens implementation time and significantly increases the likelihood of quickly seeing those tangible results, the efficiency gains, the cost savings, the reduced cycle times that translate into a strong ROI. It's about delivering clear, demonstrable value quickly and consistently.
And just to round off the challenges section to stay at the cutting edge, AI and digital twin technologies are constantly evolving at breakneck speed. How do they ensure continuous development and avoid becoming obsolete in such a fast-moving tech landscape?
That's crucial for continuous AI and digital twin development. You can't rest on your laurels. The dynamic nature of the digital twin concept actually works in DBR77's favor here. Because the platform collects vast amounts of data, both real operational data from clients and synthetic data generated from simulations. This provides an incredibly rich and diverse training ground for their AI algorithms.
So the platform learns from the data it processes.
Constantly. It allows their AI models to continuously learn, improve, adapt, and become more sophisticated over time. The more data, the smarter the AI gets. Furthermore, that direct cooperation with her large network of technology suppliers and integrators via the marketplace ensures that data on new hardware capabilities, new sensor types, and new automation solutions are constantly updated and integrated into the platform.
Keeping up with the hardware side, too.
Yes, ensuring compatibility and leveraging the latest tech. DBR77 also possesses advanced spatial analysis functionalities, allowing it to work seamlessly with the latest AI models for things like optimizing physical layouts or analyzing worker movement patterns. This commitment to continuous learning and integration keeps the platform at the forefront of industrial innovation.
Okay, so having delved deep into the challenges, the critical role of data, the power of simulations and digital twins, the real-world results, and even the hurdles of implementation, what does this all mean for a company that's listening right now and thinking, okay, I want to start this journey of optimizing my operations? What are the practical steps they should take to implement such an optimization strategy? And maybe let's revisit just how important the people involved are in this whole process.
Right, let's bring it back to actionable steps. The path to operational excellence, even when leveraging these advanced technologies, typically follows a clear and logical sequence. It's a structured approach. First, you absolutely need to analyze the current state. You have to know where you are before you could figure out where to go. This means using robust data collection, whether through sensors like DBR77s or other methods initially, to thoroughly identify the most pressing problems, the real inefficiencies, and those hidden bottlenecks within your existing processes.
You can't fix what you don't fully understand. That's where the granular IoT data collection we discussed earlier becomes absolutely indispensable, right?
Exactly. It provides the objective foundation. Once you have that deep understanding, the second step is process modeling. You create that digital representation, your initial digital twin of your existing workflows. This allows you to accurately visualize, Analyze and understand the current state of your operations in a detailed virtual environment. You can see the flow, see the delays.
Building the virtual replica.
Precisely. The third step, and this is where the real transformative power comes in, is to simulate variance. This is where you test different layouts, different work methods, different machine settings, staffing changes, all virtually, safely, without any disruption to your live production. You run those hundreds of what-if scenarios we talked about.
Exploring the possibilities. And once you've run those simulations and objectively seen the outcomes, maybe comparing dozens of different potential approaches.
Then you move to step 4. Select the best option. This crucial decision is made objectively, based on the concrete simulation results and the supporting data analysis. It's not based on gut feeling, tradition, or who shouts loudest. You're choosing the option projected to be the most efficient, most beneficial, and least risky path forward based on the evidence.
Data-driven decision-making.
Absolutely. Fifth, you then implement the changes. You execute the chosen solution in the physical world, but you do it with much higher confidence and minimal risk of disruption because you've already thoroughly tested, refined, and validated it in the digital realm.
Less guesswork during rollout.
Much less. And finally, and crucially, step 6 is continuous monitoring and improvement. This isn't a one-and-done project that you finish and forget about. It involves ongoing data collection, tracking the results of your changes, and looking for further optimizations. It ensures that efficiency is not only achieved and maintained, but continually enhanced as market conditions shift or production needs evolve. It becomes a cycle.
An ongoing process of refinement. Okay, that makes sense as a structured approach. But this leads us back to a truly crucial point, one that maybe gets overlooked sometimes in all the excitement about the technology, the human element. Technology is an incredibly powerful tool, but its ultimate success seems to hinge entirely on the people using it and the people being affected by it. How critical are employees to this entire optimization process?
The critical role of employees cannot be overstated. Frankly, it's often where many well-intentioned optimization projects falter or fail to deliver their full potential. Successful optimization, regardless of how advanced the technology is, depends fundamentally on the involvement, the engagement, and crucially the buy-in of people at all organizational levels, from the boardroom to the shop floor.
Because you're changing how people work.
You are fundamentally changing how people work, their routines, maybe even the skills they need. So their acceptance and cooperation are absolutely essential. It's vital to have clear, consistent, and honest communication about the goals of these changes. And importantly, you need to actively demonstrate the benefits to the employees themselves. This isn't just about boosting company profits. It's about explaining how these changes will genuinely make their jobs better.
How so? What kind of benefits for them?
Maybe it reduces physical strain, eliminates tedious or repetitive tasks, leads to better work planning and less chaos, improves safety, or even makes their work more interesting by allowing them to focus on higher value activities. For example, demonstrating clearly how a new layout reduces their walking distance by 30% each shift, or how automating a data entry task frees them up to focus on quality control, finding the what's in it for me for the employees.
So it's not just do this because management said so, but here's how this helps you and makes your job better, safer, easier.
Precisely. That fosters buy-in. Training and workshops are also key here. They help build understanding and acceptance for the new processes and tools. It demystifies the technology, addresses fears and misconceptions, and empowers employees with the new skills they need to succeed.
Building confidence and capability?
Yes. Furthermore, and this is often a goldmine, it's absolutely critical to recognize that frontline workers, those directly on the factory floor or in the warehouse, can be an invaluable source of innovation themselves. They're often the ones who intimately understand the daily pain points, the subtle quirks of the machines, the informal workarounds that exist. They can provide invaluable ideas for further improvements that engineers or managers in an office might never conceive of.
Tapping into that ground-level knowledge.
Absolutely. Engaging them actively, soliciting their feedback, and involving them in the design and testing of solutions not only fosters acceptance and reduces resistance, but also unlocks new, practical, and highly effective improvements that can dramatically accelerate the optimization journey. It really needs to be a true partnership between human ingenuity, experience, and technological capability.
That's a great perspective. Okay, we've seen how DBR77 addresses specific challenges with its integrated solutions and serves as a fantastic example of modern optimization in practice. But zooming out, what's the broader vision here? How does this all tie into a larger ecosystem for industrial transformation? And what does the future hold for platforms like this?
That's an excellent question, because platforms like DBR77 aren't just selling a piece of software or a collection of features. They're truly building a unique, comprehensive ecosystem for industrial excellence. As we've discussed, it's a platform that brilliantly combines the Internet of Things for data collection, advanced digital twins for simulation and predictive analysis, cutting-edge artificial intelligence for insights and automation, and that intelligent marketplace for seamless integration with other technologies and partners.
Bringing all the pieces together.
Exactly. It represents a genuinely holistic approach to digitization. It covers the entire life cycle, from granular data collection at the source, through sophisticated analysis and virtual simulation, right up to supporting automated decision-making and continuous improvement. This allows for both very precise operational optimization in the short term, fixing today's problems, and also enables robust, strategic long-term planning for the entire enterprise. Where should we invest next? How can we adapt to market changes?
And how is this comprehensive ecosystem built to be sustainable? We touched on the business model. Can you elaborate a bit on how that ensures its long-term viability and supports continued growth and innovation?
Sure. As mentioned, DBR77's revenue streams are primarily designed for sustainability and predictable recurring income, which is key for a SaaS business. They come mainly from software as a service, SaaS subscriptions, for accessing their core platform services, the digital twin modules, the AI analytics, the simulation tools. Pricing might vary based on scale or features used. Then there are commissions from the marketplace, a percentage of transactions facilitated between technology suppliers and clients finding each other on the platform, and potentially IoTT, industrial IoT service fees, perhaps based on the number of monitored devices or for providing more advanced, bespoke operational analyses.
So mixed, but focused on recurring revenue.
Exactly. While some marketplace revenue might be one-off or project-based, the strategic focus is strongly on building that base of recurring subscription revenue. This is crucial for financial stability, for funding continuous innovation in R&D, and for supporting predictable growth over the long term.
And they're clearly investing heavily in building that broad network of partners through the marketplace. That sounds absolutely crucial for such a multifaceted platform and for expanding its reach globally.
Absolutely. Building a collaborative future is central to their vision, and DBR77's partner programs are extensive and strategically vital. They recognize they can't be experts in everything. The ecosystem encompasses a wide range of collaborators, specialized software houses providing niche applications, system integrator who handle the implementation on the ground, technology providers offering specific hardware or sensors, and even management consultants specializing in process improvement. All can be part of the DBR77 partner program and marketplace.
So it creates mutual benefits.
Definitely. Partners gain invaluable access to DBR77's advanced tools and platform, potentially receive marketing and technical support, get direct access to qualified project leads through the marketplace, enjoy faster and smoother transactions, can expand their own service offerings by integrating with DBR77, and become part of a growing global network for knowledge exchange and co-innovation.
It really aims to be a comprehensive, collaborative environment where everyone involved benefits.
That's the goal. A rising tide lifts all boats, fostering innovation across the entire industrial tech landscape.
So finally, looking ahead, what's next for DBR77 specifically, based on the materials? What's on their roadmap and what's their global ambition for shaping the future of industrial operations?
DBR77 appears to have a clear and ambitious roadmap laid out. In the short to medium term, roughly through 2024-2025, the focus seems to be on solidifying their position in their domestic market, likely Poland, through successful pilot projects and full-scale implementations. They're also focused on finalizing their seed funding round to fuel growth and, of course, continuous product development, enhancing existing features based on user feedback and adding new capabilities to the platform.
Building a strong foundation first and longer term.
Looking long-term, say from 2026-2030, their strategy outlines ambitious international expansion. The plan seems to be targeting Western Europe first, then potentially the USA, and eventually Asia. This expansion will likely involve building local teams or strengthening partnerships with regional system integrators to effectively adapt their offerings to new markets, ensuring cultural fit, regulatory compliance, and local support.
And technically, integrating with other systems.
Yes. A key part of this long-term strategy also includes deepening the integration capabilities with external enterprise systems like ERP, MES, and WMS. The goal is to create a truly complete and interconnected digitalization ecosystem for their clients, breaking down data silos between operational technology, OT, and information technology, IT.
And they even have a fascinating vision that extends beyond current automation, touching on what's being called Industry 5.0. That sounds like thinking far, far ahead.
Indeed. It's a fascinating glimpse into where they see the future of industry heading. Their Industry 5.0 vision, as described, involves moving beyond pure automation. It's about connecting intelligent automation robots, smart machines, with personalized employee support and collaboration. It's about managing both robots and humans in a fully integrated symbiotic way to optimize overall operational efficiency, while also enhancing human well-being and leveraging unique human skills like creativity and critical thinking.
Human-centric automation.
Exactly. This highlights their commitment to continuous innovation, potentially including things like advanced synthetic data generation for training increasingly sophisticated AI algorithms, and expanding analytical modules for even faster and more nuanced inefficiency detection and elimination. The bigger picture is that DBR77 isn't just offering tools. It seems they're aiming to build a future-proof framework for industrial businesses. It's about empowering companies worldwide to fully utilize modern technology, breaking down the traditional barriers to digital transformation, and simplifying complex decision-making to foster dynamic, resilient growth in a rapidly changing global market.
What an incredible deep dive. We've covered so much ground today, from identifying hidden bottlenecks to the vital role of granular data, the truly transformative power of digital twins and AI to predict and prevent problems. And we've seen how a platform like DBR77 integrates these cutting-edge technologies in a practical way to turn those long-standing, frustrating industrial challenges into very real, measurable competitive advantages.
It's really about moving from reactive firefighting to proactive, data-driven optimization.
Absolutely. So here's a final thought for you, our listener, to consider as we wrap up. In a world increasingly driven by data, how might adopting a digital twin mindset, even in smaller aspects of your own work or maybe even your daily life, reveal hidden patterns? How might it unlock new levels of efficiency you hadn't even imagined? What process, large or small, could you begin to observe and measure more closely, perhaps just systematically, just to see what surprising insights emerge?
It's a powerful way to think. The future of efficiency, driven by data and intelligent systems, is truly already here. It's waiting to be discovered and leveraged. If you're intrigued by the power of digital transformation and intelligent systems, particularly in the industrial space or even more broadly, we strongly encourage you to explore more about IoT, AI, simulation technologies, and platforms like DBR77 that are making it accessible.
The journey to smarter, more efficient operations is definitely underway, and the potential for impact is immense. Thanks for joining us on this deep dive.